It's not too long of a presentation, but hopefully even you will get something out of it. Okay, so we're talking about how to understand and think about code. So what does it mean to say you should code something? Programming languages are just like regular languages, English, German, etc. But they have some differences. And the differences are primarily that they possess a very limited vocabulary. So our languages have a lot of words for describing different things, but programming languages are very, very limited in their vocabulary. Also, they are very explicit, and they never imply anything. So when you talk to somebody, you might get some hints from body language or context. In programming, there's none of that. So as a programmer, you're someone who's going to translate from business requirements to this language, to this programming language, using the very limited vocabulary. So does that mean that we're just doing what Google Translate does? Like put one language in, get one language out? Sort of, but not really, because computers are dumb machines. My math teacher used to always tell me, computers are dumb machines. If you use a calculator, it's only as smart as exactly what you type into it. It won't notice you made a mistake. People can read between the lines. Your client might say, oh, my job involves the following, or I do this at work, and I want you to build a website that does the same thing. A good programmer would know that people are leaving details out. People almost never completely describe what they want you to do or what they want you to build. Computers don't have that ability. They read only what you ask them. So if someone is going to be saying, this is what I do at my job, give me the code for it, and the computer does a literal translation, they might technically get what the person literally asked for, but it's going to miss a lot of what's actually required. So programmers comprehensively translate tasks using a limited vocabulary in a language that's unnatural to humans. And that's why programming is hard. So there's a lot of programming languages out there. We've already worked with HTML and CSS. But each language has different vocabulary, and it also talks to something different. So HTML, its vocabulary are the HTML elements, div, span, etc. And web browsers understand HTML. So what I mean by that is if you write HTML, Google Chrome is going to read what you wrote, and it's going to say, this is what I understood. Internet Explorer will also read the code, and it might have a different interpretation. So the browsers are the ones that HTML is talking to. CSS is similar. Its vocabulary consists of styling, positioning. Browsers understand it. And CSS understands input from web browser users as well. It's very limited. So what I mean by that is, when you put HTML on the page, it's just there. You can't tell the HTML to do something at that point by speaking in HTML. But for CSS, you can style the page, and when you move your mouse over a link, the link can change color. So CSS actually listens for certain interactions from the web browser. So when you're programming with different languages, especially after HTML and CSS, you have to sort of think about, to accomplish my goal, how do I use the vocabulary this language provides, and how do I send information to the browser? PHP is more advanced, of course, than HTML and CSS. So its vocabulary is more expansive. It deals with data. It can read data, save data to something else. It can create files, etc. PHP can talk directly to the server that it resides on. PHP waits for the previous line to finish before running the next line. So it runs in order, top to bottom, with certain exceptions. If you call a function, it'll jump to that function. Let's see. And at the end of the day, your PHP script will return the output of the code to the server. So web servers understand PHP, not web browsers. So Google Chrome does not understand PHP. But that's why we installed a Linux server on our machines, because this Linux server that's powered by Vagrant can understand PHP. PHP can also understand the web server. So that means the web server can have certain information, like it can have the time zone stored on the web server. And PHP can talk to the web server. PHP can say, okay, web server, what's the following value? What's the current time? What did the user type into the URL? What cookies does the user have? PHP can talk to the web server. So if you're writing PHP code and you're thinking, how do I accomplish the following task? These are the restrictions you're working in. This is the vocabulary that PHP can use, and PHP can talk to web servers back and forth. So if you're thinking something like, okay, when I move my mouse over this link, I want the following PHP code to execute. You have to realize PHP does not talk to the browser, so that's not an option. There are workarounds to do it. Developers have to look at all the languages that are available to them and think within the restrictions of each language, how do I accomplish what I'm trying to accomplish? And JavaScript is one more language that I'd like to mention. So it has a lot of the same abilities that PHP has, but it's understood by web browsers. So Google Chrome understands JavaScript, which means you don't need a server to run JavaScript code. You can just type it like we did at the start of the semester with HTML and CSS. You can just type JavaScript, open up your browser, and it can work. It understands interactions with the web browser. So you can move your mouse, you can click something, drag something, etc. And JavaScript will understand it. Let's see. That also comes with security risks, because if JavaScript is speaking to your browser back and forth, then regular visitors to your website can just inspect the code in your browser and modify it. So sometimes you'll have to combine languages. You can use JavaScript for interactions, knowing that regular users have the ability, technically, to change the JavaScript code you're running. So you don't want JavaScript to have security implications. Like, you don't want it to have access to secure data without additional checks behind it. All right, so let's try to walk through an example of translating a goal into a programming language. So we'll make up a programming language for this example, IRL for in real life. So this is the in real life programming language. It controls people. So the very limited vocabulary includes load person, which is how you would tell a person to do something, or how you would control a person. Rotate joint, make the person rotate a joint. You can make them say a word. Locator, you can find a location. And you have the ability to create variables, meaning you have the ability to store values. So who understands this language? Humans. It can control your mind, and it can tell you what to do, and you will do what it says. how do you, or what does it understand? So if I wanted to send information to the language, in this example, our only option is to follow Debug Academy on Twitter or to subscribe to the newsletter. It doesn't understand anything else. So if you want a back and forth conversation, that's as limited as you are. You only have that ability. All right, so what if we wanted to make a user sit down? So you have somebody standing up and you want them to sit down. You have to do this within the confines of the language. So first you load the person. So the idea here is you'd get a person to follow you on Twitter. So if somebody's standing, you have to just tell them, follow me on Twitter so that the code can start. And I'm gonna act this one out. Okay, so we're gonna rotate the left knee 90 degrees slowly. We're trying to get me to sit down. This is gonna look funny, walking in without the context. So you rotate the left knee 90 degrees, and then we're walking through a mock programming language, trying to make a user sit down. So you make them rotate the left knee 90 degrees, and then you make them rotate the right knee 90 degrees, and I haven't rotated anything else, so that would make me fall down. And you might write this code thinking, okay, this is what's going to make them sit down, but yeah, in that order, it doesn't work. Yeah. And this is kind of what makes programming challenging. You work within the confines of the language, and you write out what seems to make logical sense, but nothing's implied in programming. So it may be obvious to you, but it's not obvious to the language. So at this point, we'd go to Google, we'd figure out, how do I make the joints rotate at the same time in this language? And you'd find in this example, in this made-up language, instead of writing them on different lines, you just do it like this, and you learn that the syntax somewhere on Google, Stack Overflow, this will make it so that all three of those happen at the same time. So we try it again. Left knee rotates, right knee rotates, or joint rotates, and the hip rotates in the opposite direction. Hallelujah. We have functioning code. It works on my machine. You can ship it to the client. Let's see what happens. All right, so here's another example. What if your client says, okay, great, you got someone to sit down. Now make the whole room sit down or stand up. The client, of course, thinks this is easy because you just do the opposite, but they're not aware of the limitations of this language. And this language we're discussing relies on people following the account on Twitter before it can even start telling them what to do. So the only way to make this work is if you make the whole room follow you on Twitter or follow the newsletter. But nothing's implied in programming, so we can't just assume the whole room is going to follow us on Twitter. So how do you do this? You can look at the language. At this point, we're in the research phase. We'll check, what does this language have available to us? What's the syntax of this language? Remember, the vocabulary includes load person. So if you put a person's name in, you can tell it which person to control. It also has the ability to make a person say something. And it's understood by any human, and it only understands Twitter followers or newsletter subscriptions. So an experienced programmer seeing this information might come up with something like this. First, you have to take a manual step. You have to know the teacher's name. You have to tell the teacher, okay, when you're going to start class, follow us on Twitter. Like, you have to kick off this script manually. So the teacher will follow it on Twitter. And then within the confines of the language, you can make the teacher say, follow Debug Academy on Twitter. So the teacher will say that out loud. And hopefully that would result in the class, at least in theory, the class would follow on Twitter, which can trigger the rest of the code to work. So the next Twitter follower, you have this code written for them. The attendees of the class follow on Twitter, and then they do the opposite of the code we had before. They rotate their knees in the opposite direction and their hip in the opposite direction and stand up. Again, this code might work on the developer's machine, especially for one person, because you put them in an awkward situation where they feel obligated to follow you on Twitter. In a big room, probably 90% won't actually do it. But nonetheless, you're working within the confines of the language. Your recommendation could ultimately be this language can't handle what you're asking for. But what if we have a room full of a lot of people? You might say, okay, run that code for the next follower and do it again and do it again. And this will turn into a ridiculously long script, especially depending on how many people you have in the room. You might need to write that once per person. So you might think, this is working, this is great, I'm just going to keep writing this and I'm fine with it. I have something that works. That might be true if it's just you programming. But as soon as other developers join the project, this code might not be quite so good. All right, so what if the task is even more complicated than that? Make the latest follower go to Chipotle. All right, try to figure that one out. Okay, we'll load the person. We do have a locator function in this language, so we can find where Chipotle is, and we can find where the person is. You could calculate distance, Chipotle's location minus the person's location. If the distance is greater than 0, so they're not in the same place, then you make the person walk. Rotate the left knee 45 degrees, left ankle 25, right knee negative 45, right ankle negative 25 degrees. And you're writing out the code to mimic walking. Blocked at the bottom, but we're not finished with our code, and this is getting really complicated. At this point, you just maybe quit, because this language is not going to be able to handle this. So that's pretty much the end of our fake language example. But that's kind of how programming works. You have to look at the limitations of a language and work within it. Something I find with beginner programmers is you'll often ask them to write some code, make this appear here, or add a tax rate to my website, etc. And people will start to think about writing the code in English, basically. They'll think, where's the code that says blank? Where's the code that says exactly what they asked for? And that won't exist in the vocabulary of the language. So you need to look at what the vocabulary of the language is, what is listening to the language. So is it a browser like Google Chrome, or is it a server? And what does the language understand? Meaning, what information can I give to the language? So if they take information from the server, then maybe you're looking to send information through the server that the script needs to run. If they take information from the browser, then maybe you're looking to print something out on the page that the browser would have access to. Right. So in general, these are some tips for writing code. And I didn't come up with these acronyms. The KISS rule, which is keep it simple, stupid. Dry is don't repeat yourself. If you're writing the same code repeatedly, then you probably want to create a function for that code. A function is something you can call that just has a block of code for easy access. Single responsibility, ensure every function does one thing and does it well. It's very easy to get into a habit of creating functions that accomplish a goal instead of accomplishing a task. And when you do that, it becomes hard to test your code. If your code isn't working and you have a function that does a lot of things, it's hard for you to tell where is my function not working. But if your function has a single responsibility, like given this information, return this information, then it's easy to test each function in your code and find out which of the functions isn't working as expected. Separation of concerns. You want to be able to write your code so that it's distinct and not more tightly coupled than it needs to be, not grouped when it doesn't need to be grouped. You ain't gonna need it is another popular phrase. So if you're writing code and your client asks for something and you have this great idea of something they'll probably ask for in the future, you should not write the code for that idea, because it's very common to do that. I do it too, and I'll actually write the function. It's a hard rule to follow. But basically, in the best case scenario, the client does need it. And okay, great, you've written it. You don't have to write it again. In the worst case scenario, they're not going to need it. So you've wasted your time and you've added code to the code base that now somebody's going to come across in the future and wonder if it needs to be updated or where it's being used, etc. Make it work, then make it good. In our example from a few slides ago, where we're trying to make everyone, stand up in the room, we were repeating code a lot, and that code was probably not very efficient. But that's okay. That's a good first draft. You should make it work. And once it's fully working, then you can look back at it for where you can optimize it. And you want the naming to be easy to understand. When you create variables in code, you can name them whatever you want. You can name it A, you could say A equals 5, A equals whatever. But that'll really come back to bite you a month later when you come back and look at your code. So you want to choose names that are self-explanatory. There's a saying, there are only two hard things in programming, and I've mentioned this earlier in the semester. One is caching, two is naming things, and off by one errors. So naming things is deceptively hard because you don't want to overly restrict something by the name, but you also want it to be descriptive of its intended purpose.